So, in your syllabus, we have the classification and examples, and after that, they have given some of the general topics which are of much importance. So, here in the fishes, it's totally 8 hours portion as per as my knowledge goes. After we have already completed 6 hours, 2 more hours or 2.5 hours we may require. There are two important general topics. One is the fish migration and types of scales and fins in case of the fishes. So these are the two important things. So today I would like to start with the scales in the fishes. I will take up the migration in the end. First let me complete on the scales in fishes and then move on to the uh, fins in fishes, and then lastly to the that we will discuss the fish migration. The scales in fishes, all of you know, when you think about the fish, you always think about the scales, which is protecting it externally on the skin. It is not only in fishes, in many vertebrates, there is an exoskeleton. The skeleton which is found outside the body. That means covering the body. So these scales which cover the body are made up of two types of scales. One is epidermal and another one is the dermal. There are two types of scales. One is epidermal scales and another one is the dermal scales. Epidermal scales are cornified derivatives of the Malpighian layer of the epidermis. That means these are the scales, they originate from the epidermis, the outermost one is. They are very well developed in the terrestrial vertebrates. You can see in case of the reptiles, birds and mammals also there are scales. And they are epidermal scales, they are cornified derivative. Whereas there are dermal scales. Dermis is the layer below the epidermis in the skin. These dermal scales are mesenchymal in origin, and this type of scales are more prevalent in the fishes. In terrestrial organisms, most of the scales are epidermal in origin, but whereas in the fishes, they are dermal in origin, especially mesenchymal in origin from the dermal layer. So these dermal scales are generally very small, thin and cornified. So as a result of cornification, they become hard and protective. Even sometimes there can be, it may be impregnated with calcium salts. So that's why they can become calcareous also, or maybe with some bony material and bony plates or scutes which may fit very closely together, and even they can overlap also. As regard to the arrangement of the scales on the body of the fishes, they are most often imbricated. They are imbricated. As a result, they overlap like the tiles on the roof. You might have seen how the tiles are fitted on the roof. That is fitted one above the other. The margin of the one tile rests on the margin of the other. So that is how these scales are also fitted on the body of the fishes. Usually in each scale, their free margin is directed towards the tail. Why it's directed towards the tail? Because when the fishes swim, it will minimize the resistance. Suppose if the margins are oppositely directed, instead of facing toward the tail, if they are facing toward the mouth, means while swimming they will offer more resistance and it will be a very costly affair for the fish. So that's why the free margin of every scale is directed toward the tail. These scales vary in size, shape in different species. The body of all fishes except the member of one family, that is Siluridae, and few bottom dwelling fishes, that is the covered by scales. All fishes except the family Siluridae and some of the bottom dwelling fishes. In almost all fishes you can see the body has been covered by the scales. Uh, Usually the scales are found covering the entire body surface. Uh, but there are certain exceptions. Some fishes such as Chimera, Poliodon and Accipenser, uh, where the scales are not found throughout the body, throughout the body surface, instead of that they are localized, or in some areas of the body you can see the scales. In the remaining part the skin becomes naked. If you go back to some of the oldest fishes, what we call the even extinct fishes, where you can, if you are able to get some of the fossils of those fishes. So this primitive fossil fishes, which were predominant during the Silurian and Devonian period, uh, they were also having the exoskeleton, but the exoskeleton was not in the form of generally scales but in the form of plates. Though some of them used to possess the scales with three distinct layers. Usually the fishes of the Silurian and Devonian period, their scales or plates were made up of three layers. The innermost layer was having some bony element, compact bony element, that is known as isopedine. Above that there is an intermediate or middle layer which is of spongy vascular bone, very spongy and vascular, whereas the outermost layer was made up of another hard substance, what you call dentine. So isopedine, the innermost layer, which was bony material. Above that the middle layer, spongy vascular bony material, and on the outside, outer layer was made out of dentine. If you look into the origin of these scales, or even on the based on their origin, there are basically two types of scales. When I say there are two types of scales, one is those which are formed due to the secretion of both epidermis and dermis. So the scales which are formed due to the secretion by both the layer, epidermis as well as the dermis. A good example for them is the placoid scales, which cover the elasmobranchs like sharks, skates and rays. Placoid scales are formed by the secretory activity of both epidermis as well as dermis. Then there are other group of scales, non-placoid scales. They are derived from dermis only, especially in all the scales possessed by the bony fishes or osteichthyes. They are non-placoid scales which are derived from only the dermis. Based on the structure, the scales are classified as cosmoid, ganoid, rhomboid, placoid, cycloid, ctenoid, different names. The different names are given. There is a special branch in zoology, ichthyology. Ichthyology is the study of fishes. Ichthyology is the study of fishes. In ichthyology there is one more branch, what is known as squamatology. That study of scales is known as squamatology, which deals with the study of scales. Ichthyology is the study of fishes, whereas the squamatology refers to the study of scales in those fishes. If you look into the structure of the fish, scales, the The scales are small, almost plastic. Plastic means with flexibility, with some flexibility, and flakes. It is like a flake which cover their body. Most fishes have scales, but not all. There are certain examples where there are no fish scales. So this uh, certainly the presence of scales, it costs a lot to the fisher because it has to invest in the production of the scales. Then not only that, it will cause some problem on body movements. In spite of that, the fishers would like to have the scales because they give protection to them. So though it is an investment and it also restricts the movement, in spite of all these things, fishers prefer scales because of the protection that is extended by these. Usually larger and heavier scale give more protection undoubtedly. If the scales are larger, heavier means thicker. Undoubtedly they provide more protection or maximum protection. But the problem is, larger and heavier the scale, the moment it affects. They restrict the swimming activity or movement of the fish. Whereas smaller and lighter scales, they offer less protection but allow greater freedom for movement. See, there is two things. Either a fish can have larger and heavier scale which give more protection, but it restricts the maneuvering. Smaller and lighter scales offer less protection but provide more freedom for movement. For example, in some the eel fishes that you have studied, the anguilla, the scales are microscopic. The scales hardly give any protection to it, but that offers more freedom for movement. Now coming to the types of the scales. Coming to the types of the scales. First, let's start with the placoid scales. As far as the origin of the scales are concerned, the scales evolved separately in the cartilaginous as well as in bony fishes. Because in cartilaginous fishes, though the scales are dentine in origin, but there is some contribution from epidermis also. So dentine or the dermis, though in case of the cartilaginous fishes, not only, almost all fishes, maximum number of fishes, the scales originate from the dermis. But in case of the cartilaginous fishes, it is not only from dermis, even there is a contribution from the epidermis. And scales of sharks and rays are made up of bone and they resemble the teeth. Shark is a cartilaginous fish, but the scales have some bony elements in that. So as a result, they are like our teeth. In the teeth, what you have? In every teeth, even in human teeth also, there is a soft central area which is called as pulp. Surrounding that pulp, above the pulp, there is a middle layer which is made up of dentine. And the outermost layer, what you call the enamel, which is the hardest part. So the placoid scales are also like that. If you look into the placoid scales, in the central area you call it a pulp, surrounding that there is a dentine, and outermost layer is made up of enamel. So that's why as they have dentine, These scales are called as denticles. As they are having the dentine material, these scales are popularly called as denticles. And commercial name is the placoid scales. They protrude out of through the epidermis, and they are not wholly covered by it also. They protrude through the epidermis and are not wholly covered by that. This is how each scale appears. The placoid scales appear like a trident. Trident ಅಂದ್ರೆ ಗೊತ್ತಾಯ್ತಲ್ಲ ಏನು ಕನ್ನಡದಲ್ಲಿ ತ್ರಿಶೂಲ ಅಂತಿರಲ್ಲ. It looks like that. Shark has a placoid scale, tiny tooth-like structure. Here, part of that is embedded in the skin because it has to pierce through the epidermis. Part of that is embedded in the skin, and only the pointed spine comes out of it. This is a tiny pointed scale. As I have told you, made up of the same material as our teeth. So this placoid scales, in case of the shark, they are backwardly directed. That's why even if you rub the shark skin, just you place your hand on the shark and rub it from anterior to posterior, you will feel smooth. But if you rub it from posterior to anterior, you feel as if you are rubbing on a sandpaper. Rough appearance will be there. This is how they are arranged. So placoid scales have a definite size. Another very interesting thing is the placoid scales do not grow along with the animal. Don't think that the smaller sharks have smaller teeth, smaller scales, and the bigger sharks will have a larger scales. No. The placoid scales are of definite size, and they never grow along with the animal. Instead, when the animal grows, naturally on the skin opens up a large enough space between the two scales, and in that gap new one grows to fill the space. So as the fish grow, more and more scales are added, and all scales are of the same size. That is the speciality of this organism. And the scales, or what you call the denticles, in case of the cartilaginous fishes, they are discrete. That means they do not overlap as you see in case of the bony fishes. The scales, the placoid scales, which are found on the chondrichthyes or cartilaginous fishes, they do not overlap. Wherever there is space, they grow. Not grow, they come up. See, this is how the placoid scales appear. So the central region is the pulp, this is the dentine, and outermost layer is made up of enamel. Most of the sharks have a complete covering of the scales. So arrangement, if you look, it looks as if repeating diamond sort of pattern. Diamond shaped structures are repeated in the pattern. So these sharks, they have a thick fibrous dermis. Dermis, as I have told you, it is the part of the skin below the epidermis, you call it as dermis. That dermis support the scales and helps in protecting them, animal. So you know, these fishes, especially the cartilaginous fishes, in some of them they are dorsoventrally flattened, such as the rays. They have less number of scales or denticles. For example, if you take the scales belong to family Ragidae, the scales are scattered in patches. The scales are scattered in patches across the pectorals and even on the head. In eagle ray, they are very few in number. In electric ray, they are absent. Only the scales which are found in the electric ray, they are modified also. That is in the form of tail spine. Whatever the spine that you have seen on the electric ray, that is nothing but the modified placoid scale. And even the devil fishes have no scales at all. So these are common. The placoid scales, see how they are arranged with the tridentine structure. Even you can easily separate these placoid scales. What you have to do is, earlier there used to be a practical, I don't know now. You have to take a small skin of shark, put some few drops of potassium hydroxide, boil it and pour the content on the slide and observe it under the microscope. You will see such structures. Each scales get separated and you can see the placoid scales. So these placoid scales are also called as denticles because they are similar to our teeth. So the interior of the scale is pulp and that receives the blood from the fish vascular system. The scales get blood, they are vascularized, especially the interior of the scale, what you call pulp, it has blood capillaries. Whereas the outside, no vascularization, it's an enamel-like substance and that is called as vitrodentine. It's an enamel-like substance only and commercially called as vitrodentine. See, this is how the pulp, this is the how it oranges, this is the dermis, this is the epidermis. The scales originate from the dermis and this is the pulp, and for the pulp there are blood vessels also. Outside there is a dentine material and then lastly the enamel material which you can see. Very similar to that of the teeth. Here it is the teeth, it is the photograph of a teeth. This is the placoid scale. They are structurally they are one and same. Then let us move on to the other type of scale, what is known as cycloid scale. Now all the scales are found in the bony fishes. These cycloid scales are thin and flexible. Translucent plates. What is translucent? Semi-transparent. What we call translucent. And more circular in outline. And if you take out individual scale and observe, that is thick in the center, that is thicker in the center and marked with several concentric lines of growth. There are lines of growth which can be used for determining the age of the fish. By counting the line of growth, you can determine the age of the fish. They are found in large numbers, especially in bony fishes having soft red fin. like labio, catla, barbus, sirena, most common freshwater fishes. The central part of the scale is called focus because it is thick and the first part to develop. Surrounding this focus, the epidermis secretes more and more secretions, and there will be growth of the cycloid scales. These cycloid scales form a protective covering over the skin, and they project diagonally in an imbricating pattern. It looks how it looks. So all the the part of the scale which is exposed generally shows less distinct ridges. The ridges are known as circuli, and the central one is known as the thicker concentric lines growth. They are, and these are, even there are certain scales which are having chromatophores. Chromatophores are colored one. So they may give color to the scales also. Anterior area lies embedded in the skin only. Then comes the cosmoid scales. These cosmoid scales are found in Crossopterygii and Dipnoi, the two groups. The external layer here, the scale is thin and enamel-like, made out of again vitrodentine. Whereas the middle layer is made up of hard non-cellular dentine-like material, and that is called as cosmoid. As why it is called as cosmoid scales? The middle layer is made up of cosmoid, and which contain number of branching tubules and chambers. See, these are the cosmoid scales, how it appears. It looks as if tiles are fitted on the floor. This is very rare scale type, but common in some of the extinct fishes, Crossopterygians. Now, today these cosmoid scales are found in the primitive lobe fins and lungfishes only. You can observe them. It has been said that the cosmoid scales evolved from the placoid scales fusing together. How we can justify is the cosmoid scales have two base plates. And similar external spines composed of vitrodentine. See, even the inner layer of the scale is made up of lamellar bone. And on the top, on the lamellar bone, lies a spongy or vascular bone. And then a layer of dentine-like material called as cosmoid. These scales grow along with the fish. If the number of scales are fixed, as the fish grows, even this also grows. Mainly the inner layer is having vascularized bony substance, that is called as isopedine. I have told you, the vascularized bony material is known as isopedine. These scales grow by addition of new isopedine material that is added by the dermis along the edges. But these cosmoid scales are not found in the living fishes. Only the living dipnoi possess thin cycloid scales, and they have even lost the cosmoid layers. So mostly the extinct groups were having these cosmoid scales. Then comes the ganoid scales. So these are the characteristic feature of primitive actinopterygians. So that's why actinopterygian group of fishes is called as ganoid fishes, because these ganoid scales are of various forms and structure. Compared to other scales, these ganoid scales are heavy and they have a hard outer layer made out of inorganic enamel-like material called as ganoin. The outermost layer is hard enough and it is made up of inorganic material, enamel-like material, and that is known as ganoin. That's the outer layer. But whereas the middle layer is cosmoid, containing numerous branching and tubules. Whereas the inner layer, innermost layer, is thickest and made up of lamellar bones. That is isopodine material. The beauty of these scales is they can grow by adding new layers to the lower as well as the upper surface. By that they can grow. And these scales are usually rhomboid and articulated by peg and socket joint, like this. Peg and socket joint, they can. These placoid scales are very well developed in Polypterus, Accipenser and Lepidosteus. So that's why this group, that is the chondrosteans, holosteans, they are popularly called as ganoid fishes. For example, in Accipenser, they form large bony scutes. And present in 5 longitudinal rows at places where there is greater wear and tear. They are like an armor to this one. Whereas in Lepidosteus, the scales are hard, polished, and they look like a rhomboid plates, fitting edge to edge. Thus, forming a complete armor around the fish. The scales of these fishes have lost the middle cosmoid layer. As a result of the loss of cosmoid, they are thin and less rigid. The scales in one particular fish, that is Amia, which also has ganoid scales, though it's very thin because even it does not possess the ganoid layer, and it looks similar to that of the cycloid scales. See, this is how the ganoid scales are fitted. This can be found in gars, bichirs, reed fishes, but rare among the modern fishes. They are almost flat. What is the speciality is they never overlap. In the photograph you can see they never overlap, but fit together like a piece of jigsaw puzzle. What is there a jigsaw puzzle? Same, you can join and make a beautiful picture out of it, puzzle, but you have to identify the right piece and put it in right place. So they have a bony base layer similar to that of cosmoid scales. In fact, the ganoid scales are modified cosmoid scales only. The difference is in the outer layer, where in ganoid scales there is an outermost layer, there is an inorganic bone salt called ganoian, and they are almost diamond shaped and interconnected. Between each ganoid scale, there is a peg and socket joint. So because of this peg and socket joint, it can articulate. So the flexibility is given to the fish. So these are one photograph where you can see almost all type of placoid, ganoid, cycloid, ctenoid, different types of scales you can see here. Then lastly, the ctenoid scales. These are circular scales. You can differentiate the ctenoid scales from cycloid scales because these ctenoid scales have less serrated free edges. More than that, there are several spines present on the surface of the posterior area of the scale. And these ctenoid scales are the characteristic of most modern higher bony fishes like perch and sunfishes. See the ctenoid scales. They have a toothed outer edge which are spiny and or have comb-like ridges. Usually they are found on such fishes with spiny fin rays in basses, crappies. Here you can see the saw-like edges, teeth-like protrusions, that is known as tenae, and that gives them a very rough structure. Compared to other scales, they are more firmly attached. And their free hind parts are also not overlapped. So that's why they are intermediate between cycloid and ctenoid scales, and are also found on the different parts of the body. For your information, there are certain fishes like flounders. They may bear both the type of scales, ctenoid scales dorsally and cycloid scales ventrally. Such things are also there. In some, the scales are modified also. Some are totally scaleless or naked. Catfishes, eels, deeply embedded in the dermis. In some fishes, they become localized like chimeras. Even the jaw teeth in shark, they are modified scales. Even the teeth that have been forming the saw of certain fishes like pristis or a stingray, they are nothing but, the sting is nothing but the modification of the scales. The scales at the base of the tail of certain fishes like sturgeons fish, acanthurus, where the scales are modified into sharp cutting blades. In some fishes like cofferfish, ostracions, where the scales are in the form of polygonal bony plates, where they give rigid protection with articulation. If you look into some of the puffer fishes like tetraodon or porcupine fish, diodon, the scales are elongated and they look like a spine. And you know, even certain fishes, they are modified to form gill rakers. The seahorse which you have studied, hippocampus, pipefish, scales are fused to form protective bony ring. Scales are modified, fused, and they to form protective bony rings around the body. So, just the cycloid scales. Uh, we need not go to the details now. It is the time has come. We will continue in the next class. There is no time for me to continue that. Anything else? Yes? Any doubt? Just tell me. If not, we will meet in the next class. Okay, for now I will stop. Thank you for attending.